Hello and welcome to another Data Scholar Code Along. This time we're going to do a basic Twitter sentiment analysis around tweets that are on the subject of COVID-19. The data set we have here runs from about June 2020 to August 2020, so it's only a small data set. You can do this with your own data set. There are plenty of great COVID-19 tweets data sets on Kaggle, and you can just import them here or download them and move them to your workspace. I'm just using a small one just to demonstrate how Twitter sentiment analysis is done. Feel free to find your own data and follow along. It pretty much will run the same regardless of the data you get, because it generally comes out in the same sort of formats. Okay, so the first thing we need to do is import the libraries. If you're using Google Colab, Plotly Express, which we're going to use for some visualizations, is not installed into Google Colab automatically, so you need to just run that. These are the libraries that we need to import, and I'm not going to sit here and type them all out, as it'll be a waste of time. So take a look at these. Pause the video now. Make sure you get all of these in, and then when you're done, restart the video and we'll get cracking. Okay, the first thing we need to do, import the data set. So we will call it df, and we need to use the pd read csv, and our data set in this instance is called COVID-19 tweets.cv. Okay, and let's take a look at the first 5 rows. There we go. So we've got a couple, a number of different columns: username, location, followers, blah blah blah. The date and the text are probably, are something that we're going to use. We don't necessarily need everything else, but we'll get to that in a moment. Okay, let's move that up. And the next thing we're going to do, let's just check shape of our data set. And we've got 179,000 tweets and 13 columns. So as I said before, let's get rid of the columns we don't want and extract the ones we do want. So we want the username, we want the date, and we want the text of the tweet. So we will create a new data frame and we will pass in our columns, and then we'll take a look at that just to make sure that that's worked. There we go. Yeah. So we've got the username, the date, and the text. Perfect. So let's do a little bit of pre-processing. The first thing we want to do is change the username to a category code, and probably a couple of privacy issues around it as well. If you were to use this, in business kind of thing, it's probably better to keep people anonymous. And we will change the date to a date time in Pandas as well. So let's do that now. So username equals df username, and we want to set them first to a category type, and then after it's set them as category types, we can then convert them to codes by using cat codes. And while we're here, we will change them to a date time, the date column to a date time as well. So we use the pandas to date time. We pass in the date column and et date, and we can check that has worked. So once we've run that, you can see that the username has been made into a code, and we've also just used the date as well. We don't really need the times of when they were posted, although more specific analysis, for a reason where you needed the times of the tweets, that could be done. Okay, that's great. So let's extract the texts, so the tweets, and we do that by, let's just make a new variable which will point to our text column. and extract them so we can take, do some further processing on them. There we go. As you can see, it's correct. It's captured them all. Cool. So the first thing we're going to do is remove any URLs in the tweets. We don't want things that will skew the sentiment analysis, and URLs aren't really going to have much of an effect on that. So we will use a lambda to do it. And all we have to do is use the re sub, and we copy in the sort of pattern. So the string will begin with HTTP S. Let's just get that in there as well. And we will replace it with a non-character, and we pass in X there as well. Okay. And we will make a new variable called text LR, and we'll apply that lambda to our texts. And if we are able to look there, that should do it. And it'll remove all the URLs within this specific pattern. There's none on the preview there, but you can, if you wanted to dig deeper into every single line and find the URL. Oh yeah, there's one there actually. So see there, it's got COVID-19 HTTP, and on the same line, it's been removed. So happy days. Okay. So the next thing we're going to do is convert everything to lowercase. So let's just do to lower, and we do this because it's just easier for the tokenizer. And we'll use another lambda function, and it's simply x lower, and we'll make another variable, so text lr, and we'll call it lc as well, lowercase, and it'll be text lr dot apply, and we pass it in our lambda, and then let's just see if that's worked, and we'll just print the data frame as it is, and as you can see, it's changed everything to lowercase. Cool. Now, the next step, let's remove punctuation. Now, you could do this in like a for loop or a function, not a problem, but just for ease of explainability and show how it's done, that's why I'm doing it all separately. It's just so it's very clear. There's there's defined steps to this. But in a sort of, if you were to put this to production for whatever reason, you would probably lash all this in a function and it'll do it much quicker. But for teaching purposes, let's just make it very basic and break it down step by step. Okay, so let's remove the punctuation. So remove punc, do another lambda, and we use the translate string make trans, and what we're doing here. So what would usually happen if you wanted to replace the word powerful, for example, with something else, you would put powerful there and it would be replaced with something there. But as we're not wanting to replace anything, we just want to remove the punctuation. We can leave them blank, and we can use the string punctuation here, and that will remove the punctuation. So let's make a new variable, carrying on from the other one. So lowercase and no punctuation. And we'll pass in our previous variable, dot apply, and then pass in our lambda function. And then we'll preview that. So let's just tell you what, just copy and paste it rather than type it. Okay, let's run that, and it will remove all the punctuation. So you can see like the at signs and whatnot have been removed. Cool. Okay, now we're going to remove stop words, but we're also going to remove some hashtags and whatnot that I have previously looked at in this data set. So I'm going to paste them in there. If you want to pause this video, take a look at these stop words that they may influence the sentiment analysis, so we don't want them. So I'll just paste them in, pause the video, and take a look at them and type them up. And when you're ready, let's unpause the video. Okay, so stop words. We're going to use a set, and it'll be stop words, words, and we want English. Stop words dot update, and we're going to pass in more words that we've set here that you should have now if you've stopped the video and copied them. It would be an interesting experiment to leave them in and see how it affects the output compared to this one. Okay, so now we're going to remove the words, and again, use a lambda, and we are going to use a join and then a list comprehension. So word for word in X split, if word not in stop words. Okay, and let's bring in our previous function, and we'll apply it to that function by passing in remove words, and then we will we need to add, let's just add that because that will mess it all up. So ns, so no stop words, there we go, and we will check that out again, and that should do it. So remove all the useless words, shall we say. There we go. So if you take a look at the top line, originally it was if I smelled the scent of hand sanitizers today. Instead, it says smelled scent hand sanitizers today, someone. So if you can see that, removing the stop words really defines the key words in the texts, which may, influence the whether it's positive, neutral, or negative. So that's why we do that. Okay, so let's make a list of all the words, and again, let's do a list comprehension. So word for line in texts, we want that one. For word in line split. Okay. And then we will print the word list. Let's have a look. Line is not defined. That's why. There we go. Let's hit that again. My spelling again. Yes. So there we go. So we've got a list of words. Oops, that appears in our texts, and tweets, should I call them rather? Okay. So what we want to do, something might be interesting. Let's take a look at the most common words. So word counts, and we will use the counter, and we'll put the word list in there, and we want the most common, and let's take the top 10, shall we? We'll take a look at that. There we go. Nice. What we'll do then, let's visualize it. So we'll put it in a data frame. Data frame word counts, and then words df, we will set the columns, and we want word and the frequency of that word, and then let's plot it using Plotly Express in a bar chart. So the data it takes is the word df that we just created. The x variable will be the word. The y variable will be the, just showing it's a frequency, and let's make a title. Most common words. There we go. Run that again. Oh, that's why, because it's not right. Not an alias, is it? There we go. That should work. Cool. There we go. So we got cases, people, pandemic, deaths, us or US, maybe, health, 1, positive, and total. So they're the top 15. And, you can play around with that. If we put maybe 50, let's take a look at it again. And there we go. So you've got all these kind of words here, like real Donald Trump, mask, India, Trump again, August, masks, virus. So yeah, cool. Right. So what we're going to do, we've got our clean text. Let's put the clean text in our data frame. So it'll be text LRLC NPNS. So there we go. We'll put that in the data frame, and then we'll take a look at DF head. Bingo. So we've got the username, the date, and our nice clean text. Okay, so let's start on the sentiment analysis, and we will use the sentiment intensity analyzer, which is a function, and it is part of what we imported before, the NLTK sentiment.vader package. So it's done automatically for us. We don't have to do it ourselves. The joys. Okay, so let's work out the polarity score. That's what the PS stands for. We'll do another lambda, and we'll bring in our instance of the sentiment intensity analyzer, and from that we will use the polarity spell scores, and we will pass in the X there, which will be obviously our DF text. So let's make a new variable, sentiment score, DF text dot apply, and we will pass in our polarity score. And then let's take a look at that. So sentiment score. There we go. And just give that a moment. It's got a lot of text to get through, so it does take 30 seconds or so, but I'll pause the video and we'll get back to it. Bingo, there we go. So it's in a dictionary format, but you can see that it gives us a score of negative, neutral, and positive, and then it gives the compound, which is basically a combination of this, to give us a score. And that's what the compound is what we use to define whether, what category it falls in. So let's tidy this up a bit and get it into a data frame. We'll call it sentiment DF, and we'll use the data frame from pandas again. And the data will be the list of sentiment score. And then let's take a look at the head. There we go. As you can see, it's a lot more clearer. There we go. And as I say, the compound is what we will be using to basically figure out whether it's positive, neutral, negative. Okay. So what we're going to do is label the compound to positive, neutral, or negative. And so let's just call a function called labelize. I haven't spelled that incorrectly. In England, it is an S, not a Z. And British English is the original, so I'm just doing that. I'm just saying. Okay, so lambda x neutral, if x equals 0, else positive, if x is greater than x, x is greater than 0, and then else negative. There we go. Very simple. It's just pretty much an if statement. And then sentiment, df, label. We'll make a new column for the labels, and it'll be sentiment df dot compound dot apply, and we pass in a labelize. And then let's check that out. There we go. So we can see the top 5 are positive. Okay, cool. So what we need to do now is join these labels to our original data frame. So that can be simply done data df join and then sentiment df dot label, and then we'll take a look at that. There we go. So there's our original data frame with the positive or negative neutral labels. Cool. Right. So let's do some plotting. So the first thing we're going to do, let's just plot the amount of positive, neutral, and negative tweets. So we'll call it count df, and it'll be the data label. We'll use something called value counts, and we will reset index as well. So counts dot underscore df. Take a look, and there's our totals there. So all we have to do now is pass that into a Seaborn bar plot, and X will be the index and Y will be the label, and the data is from counts df, and we run that, boom, and we've got a nice little graph. So yeah, there we go. Okay, so what we're going to do now is we're going to aggregate a little bit and plot the amount of negative, neutral, and positive tweets over our time period that we have within our data. So let's do that. Let's do these data aggregations. So we'll call our variable data ag, and we want to take a list. So it'll be the username, it will be the date, and it will be the label as well. And what we want to do is group by the date, and we want to group by the label as well. Why don't I keep doing that? There we go. And we want the count, and we also want to reset index as well. Let's take a look at that first. Here we go. Beautiful. So this is basically a count of how many tweets per username, if you know what I mean. And then we're just going to plot them. Okay, so let's data ag, set the columns. We want to have them date, label, and counts. Cool. So run that. There we go. Now let's plot it. So we'll use Plotly, and the data we need is from data ag. X needs to be the date. Y is the counts. We will vary the color by the label, and the title will be daily tweet sentiment. From that, and there we go. We got a nice chart, so you can, it's interactive as well. So probably, so we can see on, the 28th of July 2020, there was a count of 3,009 positive tweets regarding COVID. Okay, right. So we've done that nice little. We can see, how it's changed. I mean, like, look at that. I wonder what was happening on the 7th, but it's these are the kind of things that we can look into more in detail. And COVID isn't a positive thing. If you get COVID, it's not great. So it'll be interesting to see what these positive tweets, what the content is for further analysis. We won't go into it here. As I say, this is just a very basic and straightforward sentiment analysis, just to show you how to do it. There's plenty of room of further analysis around things like that. What makes a positive COVID tweet? What makes a negative COVID tweet? And what makes a neutral one? So that's, there's your homework. You can go away and do that. The next thing we're going to do is do a word cloud, which are quite fun and quite good for presentations and whatnot. So let's import the word cloud. Okay. And what we're going to do, we're going to extract the positive, the negative, and the neutral tweets, and we can make word clouds out of all of them, and just see what the difference is in terms of what kind of terminology they're using, what kind of words they're using. Let's just in this particular video, I'll just show you how to do it for the positive tweets. And then you can experiment with the rest. I'll just give you the template to do that. So let's first of all, we need to make a mask, and we'll call it max pos. That'll be data, label, and so that will basically extract our positive texts within this variable. So what we can do is copy and paste that, and the label, need to change that to neutral. I'll take that, change it to neutral, neutral, neutral. And then for that, we will do the negative, 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 neg there. And that shouldn't have also corrected, or did I type it? Can't remember now. And we'll change that to negative. There we go. Okay, so let's run that. Now the next step, we'll take we need to take the positive, we need to take and let's just do the pos text. So what we need to do is join and basically extract it from our positive texts. So we'll do another sort of list comprehension kind of, well, it's not really a list comprehension, it's just like a for loop. So text for text in positive texts dot text. Let's run that. And then we build the word cloud. So it will be word cloud equals word cloud. The width, let's set that at 800. Height, set that 400. We'll just go with half. Okay, the max words that we want to see is 100, so it doesn't get too messy, but you can certainly play around with that. Max font size equals 50. Background color, it's a underscore, I think, and we'll just have that as white. And then generate, and it'll come from the pos texts. Okay, so that'll generate the word cloud. No, it won't, because I've spelt that wrong. Yes, there we go. Let's run that again. And it'll generate, it might take a minute or two again. It has to, process a lot of text. And then it won't actually display here. What we need to do is build it in. So let's do a figure, fig size, and we'll do it 15, 12, something like that. PLT image show, and we want the word cloud interpolation. Spell it, yeah, bilinear. Now it's completely forgot what the bilinear part is, but I think it's the way it's laid out. It keeps it in a sort of, like, it's almost like a grid format, if you know what I mean. That's what I think it is. I can't remember, and we don't have time to check it up. But trust me on that one. Bilinear is the one that you want for a decent looking word cloud. PLT axis, you want that off, and then plt.show, and we're good to go. See what we've done. Boom. There we go. So these are all the words associated with positive tweets. Love, friend, Donald Trump, the real Donald Trump. I didn't know there was a fake one, to be honest. So yeah, that is a very brief and simple COVID-19 tweet sentiment analysis. What to repeat these for the rest, all you'd have to do is, again, pretty much copy and paste this. You maybe neg test text, join it to the negative text, and then pass that in there. Pass the negative text in there, and it'll make one for the negative as well. Again, all this part here could be looped in a for loop or in a function, which would produce 3 separate word clouds. But in sake of the teaching experience, I've just broke it down, what step by step kind of thing. But as I said earlier on, this is a very simple analysis. There is plenty of room for more in-depth analysis, but that isn't the purpose of this video. But that brings us to the end. So I hope you have enjoyed this Twitter COVID-19 tweet sentiment analysis, and please like and subscribe, and I will see you next time.